Okay, so this is the solution to one of the lab problems. The limit as x goes to 5 of 3 over x minus 4.9 equals 30. And this is pretty similar to one of the examples in the notes. So if you haven't done the example in the notes, I definitely think you should do that first. There was another video about that one. It is, what number was that in the notes? Just so I can tell you guys which it is. That was example 10. So definitely try example 10 before you try this one. This one is like very similar to example 10 with maybe like one small thing you got to be careful about. Okay, lab problems. Let's do it. So what do we want to show? For all epsilon greater than 0, there exists delta greater than 0, so that what? I don't know, which way should we put the thing? 3 over x minus 4.9 minus 30 less than epsilon whenever x minus 5 is less than delta is bigger than 0. Okay, so let's do it. We're given epsilon bigger than 0, and we want to show, what do we want to show? We want to show this thing that I just wrote. Let's write it again. Okay. Okay, so we're going to start with 3 divided by x minus 4.9 minus 30 less than epsilon. And I need an x minus 5 to appear. My target is an x minus 5. I don't see an x minus 5 yet, so what I'm going to do is I'm just going to simplify and hope that an x minus 5 appears. So let's try that. I guess I'll try common denominator and try to get this thing to work. 3, 30. Okay. Okay, there it is. Okay, this is somewhat annoying, but I guess you got to do it. 30 x minus 4.9. 3 minus 30x. Minus becomes a plus. We got plus 30 times 4.9. That's what's on the top here. It's all in absolute value, so I can just put the absolute values in like this. And I got an epsilon. Okay, 30 times 4.9. A lot of people, I think, would reach for a calculator, but not me. I'm going to do 30 times 5 minus 0.1. 30 times 5 minus 0.1. And then I can expand it. So it's 30 times 5. 30 times 5 is 150. 30 times 0.1 is 3. So 30 times 4.9 is going to be 150 minus 3. Okay, hopefully that's true. Should I get a calculator and double check? No, we're gonna stick to our guns and hope that is true. And guys, look at this. This is great. Like I got a minus 3 over here. I got a plus 3 at the front. Boom. Okay. Minus 30x plus 150. Okay. Minus 30x. Why don't I just flip that around? So in absolute values, the absolute value of a minus b equals the absolute value of b minus a. We can flip it. Let's flip it. 150 minus 30x. Is that what I want? Okay, you know what? Screw flipping it. Let's just like multiply it by minus 1, right? Oh, I didn't. Yeah, okay. Look, what I had written before, 150 minus 30x. That's not flipping it. That's just rewriting it. Flipping it would be taking this and just writing it as 30x minus 150. 30 times x minus 4.9 less than epsilon. Okay, so I multiplied inside the absolute value by minus 1. I flipped it, but that doesn't do anything, so that's legit. Okay, and now I can factor out a 30. This is great. 30 times x minus 5. Okay, that rings a bell. $30 times x minus 5. X minus 5 was the target. Now I'm in good shape. So I kind of did all these steps of simplification on faith that an x minus 5 would come out. And like, you know, you got to have the faith and just go for it. Yeah, and this one was particularly nasty because 4.9 is kind of an ugly number. But yeah, that's how it works. So let me think here. I want x minus 5. So I'm going to put the x minus 5 on his own, and I'll put everybody else to the other side. So x minus 5, and everybody else, you go away. Oh, guys, look, the 30s cancel. Nice. Okay, so what do we have? X minus 5 epsilon times x minus 4.9. Here we go. X minus 5 and epsilon times x minus 4.9. Okay, so now we are set up to do a right replacement rule with x minus 4.9. So we're going to bound x minus 4.9. And in the right replacement rule, we want to bound it below. So our lemma is going to look like x minus 4.9 is bigger than something. The something, we'll just call it b for now. And as always, we're going to have to make an assumption. So we're going to assume delta is less than something, less than question mark. And that gives us that x minus 5 is less than question mark. And if x minus 5 is less than question mark, we should be able to get to x minus 4.9 is greater than or equal to b. Okay, let's go for it. We got to fill in. We got to figure out what b is. We got to figure out what question mark is. A good way to start is to just try something. So let's just do the thing we always try. Let's try delta equals 1. Delta less than 1. And we'll figure out what b has to be. Okay, so here's the proof. X minus 5 is less than 1 and is bigger than minus 1. That's something wrong there. Okay, here, I kind of did 2 lines at once. Let's fix it. 1 and minus 1. Okay, so we're starting at x minus 5 less than 1. We're assuming delta is less than 1, and we want to get to x minus 4.9. How do I get to 4.9? I'm just going to do it in 2 steps to be safe. I'm going to add 5. So I get 6, and then adding 5, I get 4. So x is between 4 and 6. And now I'm going to subtract 4.9. So subtract 4.9. X minus 4.9. 6 minus 4.9, that's 1.1. 4 minus 4.9 is negative 0.9, right? 4 minus 4.9. Okay, so x minus 4.9 is between negative 0.9 and 1.1. And I want the absolute value of x minus 4.9 to be bigger than something. It needs to be bigger than something. I think this is a serious problem because negative 0.9 to 1.1 on the number line is like 1.1 is up here, 0 is over here, and negative 0.9 is this. So we're going from negative 0.9 to 1.1. This includes 0. If x minus 4.9 is 0, then the best thing we can do for b is 0. And 0 is no good. 0, like if we do a replacement with 0, then delta has to be 0. That's not good. That's bad. So b would have to be 0 for this to work out. And that's certainly not what we want. So yeah, I think we're screwed. Like this isn't going to work. This is not going to work. And I think what happened is the delta was too big. Delta equals 1 was too big. And I can see it's too big because I'm sort of including this range, negative 0.9. So like that's the real problem, is this like negative bit. If I can shrink the range down, to get only positive numbers, then b can be sort of like the leftmost limit here. So that's what we're going to do. We're going to try it again. We need to pick something down to shrink it down even more. And there's a lot of things you could try. And really fundamentally what's going on is that the problem is that 5 and 4.9 are really close together. So you got to pick a number that is so small that it splits the difference between 5 and 4.9, and it kind of captures the difference. So 0.1 turns out will be right on the border. 0.1 will almost work. To make it actually work, you need a number that is even less than 0.1. So I'm gonna do 0.0. What should I do? Let's do 0.02, and I think this will work. So we're gonna start over, and we're gonna do it again. And actually, what I can do is I can just fix the steps. So 0.02. Assume delta is less than 0.02. We want to prove that x minus 5 is less than 0.02, implies x minus 4.9 is greater than b. So we're starting with x minus 5 less than 0.02. And then we get x minus 5 is between 0.02 and negative 0.02. And then we get add 5 to both sides, 5.02. And this one is going to be 4.98. So x is between 4.98 and 5.02. So what is x minus 4.9? This is going to be 0.12. And on the other side, it's going to be 0.08. Okay, now we're good. 0.08 and 0.12 are both positive numbers. So I can make this work. X minus 4.9 less than 0.12 and bigger than 0.08. I want to eventually get to x.49 is greater than or equal to b, and x minus 4.9 greater than b is x minus 4.9 is bigger than b, or x minus 4.9 is less than or equal to minus b. So this is the reverse sandwich property, and I have it. Look, I have it. 0.08 less than x minus 4.9. That's what this thing says. So if I make b equal to 0.08, then I'm in business. B is 0.08. B is 0.08. Okay. B is 0.08. So let's try it and make it work. So these last lines, I can fill them in now. 0.08, 0.08. This one should have a negative 0.08. And look, if x minus 4.9 is between 0.08 and 0.12, then definitely 0.08 is less than x minus 4.9. And if x minus 4.9 is greater than 0.08, then definitely it is that or something else. And once it is that or something else, it's definitely the absolute value being bigger than 0.08. Okay, so there we go. That's the lemma. If delta is less than 0.02, then all this stuff will work out. X minus 4.9 will be greater than 0.08. Okay, so by the lemma, the lemma only works when delta is less than 0.02, we said. Now, by the lemma, assuming delta is less than 0.02 and the right replacement rule, so we can replace things on the right, we get to x minus 5 is less than, and what was the b value again? The b value was 0.08. Epsilon times 0.08. And now we're in business, because what we wanted to get to was x minus 5 is less than delta. So I can do this as long as, assuming delta is less than epsilon times 0.08, then you get this. X minus 5 less than delta, traditional last step, include this 0 thing, 0 less than x minus 5 less than delta. And that is a perfectly good proof. Going from the hypothesis to the conclusion, there was a lot of algebra at first. I really should say what delta is. So far, what have I assumed? I have assumed delta is less than 0.02, and I have assumed that delta is less than epsilon times 0.08. So to make both work, I'm going to set delta to be the minimum of 0.02 and epsilon times 0.08. And if delta is the minimum, then definitely it is meeting both these assumptions. It is satisfying this one, and it's satisfying this one. Okay, I guess technically these should have like equals, but that's fine. Okay. Okie dokie, that was the proof from this lab problem.